Okay, so hello, is that how you sit? Usually way in the back and talking to no one here. Why do you guys like to sit in the back? Right? Yeah. Sometimes I do. Ask Rachel. Okay, so familiar faces. I know most of you from analysis, with an exception. Paul, are you graduate student?
Yeah.
With who do you work?
George.
George? So you must be new then. Okay? You just, what?
Right here.
First year. Let's see. Do I know you? Yeah. I've seen you before.
Yeah, but I think now.
How come? What are you? Are you first science student? You nutrition? Cool. Switch. Okay, everyone else? Everyone else I know from food analysis. So I'll be with you just today and Friday, and I'll be covering protein ingredients with you. So today I'll be going over some trends in this field, trends of proteins, whether it's animal-based and the trends for having more plant protein-based ingredients. And then talking about how we produce these ingredients and a little bit about advantages and disadvantages of them. And then on Friday, I'm going to link some structure, characterization of these different ingredients to some functionality for food applications. So this kind of sets the stage for later lectures that you might have on any food application that requires protein ingredients. So that's kind of an overview of what we're going to cover today and Friday. Okay, so I'll start off with some throwback to what you might have learned in food chemistry about what is the benefit or role of proteins in food. So we have different roles of proteins. We have the nutritional side of things and then the structural, functional, physical side of things. So for nutritional, when we talk about the importance of proteins in food, from a nutrition perspective, we think about what's the protein going to produce or give us essential amino acids. And the requirement per day, about 50 grams of protein per day, or 1 gram of protein per kilogram of body weight. So that is a requirement for us. And then here, if you see on the nutrition label, so let's say that a serving gives you 36 grams of proteins. This represents 70% of the daily value. So 36 over 50 grams is 70% of the daily value. Okay, great. So that is one thing. And then this brings me to the ease of digestion. Also, if you remember from food chem or food analysis, even we talked about PDCAAS, protein digestibility corrected amino acid score. So a protein that has 1 PDCAAS value of 1, that means it's a complete protein in terms of amino acid, and it's 100% digestible protein. So 36 grams of proteins, let's say it's whey or egg or casein protein, they will give you, all of the 36 grams will be available. So 36 over 50 is 70% of the daily value. But if you have a protein that has 0.8 PDCAAS, then not all of the protein that you consume will be bioavailable to us. Only 0.8% of that would be, so the daily value would be calculated accordingly. So when we think about nutritional quality of a protein, we think about essential amino acid, we think of how easily it can be digested so that we can actually get that amount. Okay, other than our daily requirement, why would we need to consume high amount of proteins? If you ever want to look like that, you want to get more protein into your diet. So how do the athletes get more protein in the diet? High protein beverages, high protein bars, any high protein kind of diet to help regenerate the muscle after an exercise or build those muscles. Okay, great. If you don't want to do that, there are other benefits of proteins. So FDA in 1999, they came up with the approval of this claim that 25 grams of soy protein a day as part of a diet low in saturated fat and cholesterol may reduce the risk of heart disease. So you see, after this claim, a lot of proteins from soy have been used in different applications. Other physiological benefits has been associated with high consumption of protein is the fact that proteins, when they're digested, they might release bioactive peptides or sequences of the protein that has bioactivity in our body. So these peptides can reduce hypertension, be antidepressant, promote satiety. Other benefits for proteins, it's in aging population, they reduce muscle deterioration. So high protein diet for elderly people help with reduction of deterioration of their muscles. Weight loss, so high protein diet is recommended for weight loss, and also maintaining a good metabolic health. So protein is not just from daily requirement, has been gaining traction because of other health contribution. Now, of course, you've learned that in food chemistry as well, that proteins have other functions, and the physical functions of proteins, color. So you have the natural white color that comes with casein. That's because casein protein is light scattering. You have the chromophores like in myoglobin, which is red color in meat. And then you have browning, which is not enzymatic, like Maillard reaction in a bread. When you bake it, it gives you that brown. The protein reacts with the sugar and through Maillard reaction and gives you the browning. And then you have the enzymatic, which is not desirable with polyphenol oxidase. The action is not desirable in fruits and vegetables, but it's desirable in tea, for example, producing that darker color of tea. Flavor, proteins contribute to flavor due to the amino acid composition. So high level of hydrophobic amino acid gives you bitter, which is not necessarily something good. Acidic, you get the acidic amino acid gives you the sour taste, cysteine, the sulfur taste, monosodium glutamate gives you the umami flavor. And then you have the proteolysis that gives you the ripened flavor of cheese, with the breakdown of protein during ripening gives you the flavor. And then you have sweetness, for example, aspartame, which is a peptide of aspartic acid and phenylalanine. Together they form a peptide, and that peptide has sweet taste. In terms of texture, the protein is used as an ingredient for so many different applications. For example, forming a gel, holding water and giving a texture of a gel, three-dimensional structure. Emulsifying and foaming. So this ice cream, you emulsify, the protein emulsify because you have fat and aqueous, and also you have air, so you have the foaming. So the protein helps in emulsification and foaming. The gel formation, like in the tofu, for example, water binding capacity, water holding capacity. So if you're making a sausage, sometimes you add not only the meat in there, you add whey protein to enhance water holding, water binding, fat binding characteristics of that sausage. Viscosity and elasticity for bread, for example, different types of bread requires different viscoelastic properties that will allow the dough either to extend and remain extended like the pita bread, or to have a very nice long volume like the regular loaf bread. So what gives all of these structures are interactions. So the proteins interact with each other, protein-protein interactions like in the gel formation. Also you have protein-water interaction. Also the gel is a 3D dimensional network where you have protein-water-protein interactions. And then you have protein-lipid interaction and emulsification, protein-saccharides interaction like Maillard reaction, and protein interacting with air. So all of the different interactions are by different bonding, ionic, hydrogen bonding, hydrophobic, cross-linking. So by disulfide linkages, So you have all these different interactions that lead to creation of the structure. And you learn all about that, I hope, in food chemistry. So this is just a reminder here. And then it also, in this table, summarizes different functional properties that the protein can bring to different applications. So if you want to have a high protein beverage, the protein needs to be soluble. If the protein is not soluble, you put it into that beverage and then it sediments. And when you go to buy your drink, you'll see the protein sediment at the bottom. You don't want that. So sometimes they tell you, shake, shake. No, really shake before you drink because of the protein sediments. This is a pea protein beverage. You remember what's the, is it Ripple?
Yeah.
Yeah. So proteins that are not soluble are really hard to manufacture with, not just for producing beverages, but for anything. Any functionality requires the protein to be somehow soluble or dispersible in water. And then you have the water holding capacity, which is very important in meat products, cheese, yogurt, surimi. You want to hold on to the water. You don't want syneresis. Also in meat products, if you have more water that is bound, there's more money, free money actually. Water doesn't cost money, but then the meat weight will give you more money. So gelation also, you want gelation in meat products, scrambled eggs, yogurt, gelatin, tofu, etc. Emulsification in ice cream, in salad dressing, mayonnaise, and then foaming in different products as well. But proteins do sometimes come with anti-nutritive factors. For example, inhibitors, such as trypsin inhibitor, for example, in soy. Soy needs to be treated in a way, or thoroughly treated in a way that you have, at least you knock out 95% of the trypsin inhibitor. So trypsin inhibitor is a protein, and what it does, it inhibits our trypsin in our digestive tract. So when we consume protein, if there's trypsin inhibitor along with our food, we cannot digest that protein because it inhibits the action of trypsin. Allergenic proteins. Unfortunately, proteins can be allergenic. We have top 8 allergens currently by the FDA. Among them are milk proteins, soy, wheat, peanut, egg protein, obviously there's shellfish, and tree nuts, proteins that are allergenic. So these have to be labeled or put on the label, contains wheat or soy. Toxic components, we can generate toxic components like the carcinogenic and nitroso compounds that can be present in cured meat, and heterocyclic amines that are produced when we heat meat at high temperature, over grilled meat, for example. So the protein in the meat reacts with some sugars through Maillard reaction and can form heterocyclic amines. Lectins, a form of proteins that are found in seeds, that could also cause inflammation in the intestine. Others, evidin, is a protein in eggs. It binds to biotin, which is a vitamin, and render it biologically not available. And histamine is a vasoactive amine. So there are some anti-nutritive factors for some proteins. So with that, I shift to the demands of or the increased demand of protein globally. When we say demand of protein, not just protein ingredients, protein in general, whether like you're eating meat or you're drinking milk and eating dairy products, or you're using protein ingredients in different applications. So we have a global protein demand for our current population of about 7.7 billion. Is about 230 million tons. That's huge, and it's increasing tremendously. So why is the demand on the rise? Without looking to your next, if you have your notes in front of you, why do you think the demand of protein is increasing? Everybody is excited about protein and want to consume more proteins. Why is that? Yes?
Increasing population.
Yeah, okay, increased population. But why do we want to eat more protein than carbohydrates or fats? Oh, come on. I know it's almost 5 p.m. Everybody's tired. Okay.
Nutritional. Oh.
There we go. So population growth, also changes in socioeconomic economic status, so increasing the income, so proteins are more expensive. So, but when you have higher economic status, you can afford more expensive food. Aging population would require more protein in their diet for healthy aging. Understanding the role of the protein in a healthy diet. So far, protein has not been associated with bad health effects, except very high consumption of protein can hurt your kidney, but everything in excess is not good for us. But in general, protein has been linked to positive health effects. So if we look at the developing country, we see increases in demand for animal protein. If we look at developed country, they start looking at alternative sources of protein. For many reasons, they're looking for other types of proteins to consume other than animal proteins. And why is that? You see that we have a lot of a new trend of high percentage of vegetarian and flexitarians. And they go, why do they want to become that? Because of many reasons. One, ethical issues related to animal production. Greenhouse gas emissions, so environment concerns, sustainability, intensified pressure on the land. So how can we make sure that we have enough land that we can use for planting and production of food for long term, for the generations to come? So currently the way they produce meat is not sustainable. It hurts the environment, it hurts our land. So health concerns, eating a lot of meat have consequences in terms of health concerns. So consumption of saturated fatty acid associated with meat consumption will lead to cardiovascular diseases. Overconsumption of processed meat. So concern of health, people are trying to look for alternatives to meat. So currently, what are the existing protein supply? So if we look global, this is kind of the pie chart for the global, over 57% of the global supply of protein comes from plant-based, mostly from cereal and mostly from wheat. So wheat within the cereal is the most source of proteins. So there are a lot of nations that wheat is a staple type of food for them. Then you have the meat at 18%, dairy at 10%, fish and shellfish at 6%, and then other meat products at 9%. So talk about protein demand in general, but we're going to talk about alternative proteins and specifically protein ingredients. We look at global demand of protein ingredients, so from both plant and animal sources. It's expected to reach 7 million in 2025 with a revenue or market value of 70 billion by the same year. So it's growing and it's becoming a major sector in the industry. Of that, 40% is plant protein. Plant proteins, ingredients specifically. So when we talk about ingredients, you want to think about using plant protein, or not plant necessarily, protein flour, protein concentrate, protein isolate. So when you hear these terms, these are the ingredients. So it's not necessarily cheese or bread or meat. So when you say protein ingredients, these are the ingredients that you use for formulation, for production of protein-based products. So why are we interested in alternative proteins? So like we said earlier, consumers are seeking sustainable sources for the environment purposes, healthy, vegan alternatives that are not currently among the big 8 allergens. So that we are looking for alternatives to currently allergenic proteins. That's from a consumer perspective. From a producer perspective, we're looking at reducing the cost. Always the consumer, the producer or the industry is looking for lower cost options. So we're looking at proteins that are produced or ingredients that can be produced at lower cost. So we're searching for something cheaper than whey protein. Whey protein is very expensive ingredient. Utilizing current processing streams to increase value and revenue, something we call valorizing byproducts. So if you think about soy protein as an ingredient, 50 years ago they used to produce oil from soy and the meal goes to animals. Then they discovered that that meal has really good protein nutrition. The nutritional quality of the protein is good, the functionality is good, so they started producing it for human consumption. The same thing now they're looking at others, like canola. You're producing canola oil and you have a canola meal. What do we do with this meal? It's high in protein. Can we also leverage that protein, which is otherwise is a waste stream? Can we utilize this to produce an ingredient that has high value from a nutritional, functional, and also bring revenue to the industry? So when we're looking at new alternative proteins, we want to determine how can we put them in the market, what can we utilize them in, and how can we generate revenue out of them. And also replacing chemical ingredients with functional proteins. So instead of putting synthetic emulsifiers, can we use a protein ingredient that can emulsify so that we can remove from the label monoacylglycerols. Instead, we can put a protein from a specific source that can emulsify. And that we call clean label. That means a label that anybody can read and understand. Doesn't have any chemicals there. Responding to the growing interest in sustainable and environment-friendly sources. So consumers are calling for sustainability, so the industry wants to respond to that, so they're searching for alternative proteins. So where are these proteins used in, or why are they becoming very popular? Because if you want plant-based food, then you want meat alternatives. So what goes into meat alternative is plant-based protein. So meat analogs is a big application right now for protein ingredients that are not animal-based. So it's a growing market. It's estimated to take up to 1/3 of the market by 2050. So Beyond Meat, are you familiar with Beyond Meat? So do you know what protein is mostly used in Beyond Meat? Huh? Pea. Pea protein is the main one. What about Impossible Burger? Huh? Cream that is generated, it used to be generated from the soy root, but now they figured out a way to do it from yeast fermentation. So next we have protein beverages, like I said, high protein beverages to increase your consumption of protein, whether you're an athlete or a health conscientious individual, so you want to consume more protein, so beverages market is also increased. So protein beverages used to be mostly whey protein because it's a very soluble protein and has a very acceptable taste. Now they're looking at alternatives to whey because whey comes from an animal source. So they're looking for beverages that have pea protein, soy protein, other proteins that are from plant-based. So again, this is a huge market, and it's estimated to be about $2 billion by 2025 in market value. Dairy analogs, so non-dairy milk, so almond milk, oat milk, soy milk, but we're even going away from soy. And then cheese, non-dairy cheeses from plant-based. Protein bars is another one, and also extruded products, whether for breakfast or snacks. type of products. But when talking to industry or listening to them pitch for their needs, they tell you we want protein ingredients that are not soy and not whey. Why? Because there's a lot of stereotyping around them. First of all, there is the allergy aspect of soy and wheat. Second, you have the soy being GMO. And then wheat, there's a lot of negativity about wheat, not necessarily all true, but consumers are seeking alternative plant proteins to soy and gluten. So, what are the most common protein ingredients? We'll go over them very quickly, and then we'll talk about new and emerging protein ingredients and where they could be used, with their advantages and disadvantages. So these are your common protein ingredients. So you see a lot of products in the market are formulated with casein proteins and whey proteins. Soy proteins, you have soy flour as a main ingredient, soy protein concentrate, soy protein isolate. So when we say concentrate, usually it's anywhere between, for soy specifically, 60 to 80% protein. And then the isolate is above 90% protein. Soy flour is about 40% protein. So they're all considered protein ingredients. So they're used in so many different applications. Egg proteins, cereal proteins, meat proteins. So these are your general proteins that are very common and used in different applications. You also see hydrolysate. So on the label, sometimes you read soy protein hydrolysate. So soy protein hydrolysis sometimes is more soluble, sometimes it gels a little better, sometimes it emulsifies a little better, sometimes it provides other active peptides. So they are used as well as ingredients. So these are the list of alternative proteins, and the list is growing. So one of the big one is pulses right now, and we'll talk about it, mostly pea protein, and then emerging are more oil seeds. So soy is an oil seed / legume, but there are other oil seeds that are coming up. There are single cell proteins, insect proteins, and then other proteins are emerging from other sources. So pulses. Pulses is gaining a lot of traction. Why? Because it's very easy to grow, and then the protein is relatively nutritious source of protein with essential amino acids. And then they're becoming really popular. Even in 2016, it was called the International Year of Pulses. So if we think about pulses, what are they? They're mostly legumes. And these are peas, chickpeas, lentils, and all sorts of different beans. Those are all referred to as pulses. So if we take pea, for example, this is the most common one in the market now. It's growing really fast. You see a lot of applications or food products which have pea protein as an ingredient. So why is it being a trendy source? First of all, it's easy to grow. This is important for growers when you have short season growth. That means they say, okay, we are growing soy and we're growing corn on the land, but in between we can grow another crop and benefit the farmer from that. This would be pea, for example. So it can grow in a short amount of time, and then you can use it in crop rotation. It's a legume, and the benefit of the legume, it fixes nutrients in the soil and even nitrogen in the soil. So it gives benefit to the soil. As of now, it's non-GMO. It can be produced organically. And now, and I say that very carefully and with caution, it's non-allergenic. Okay? But something you need to know and realize that when you consume more of a certain protein, or the population consumes more of a particular protein, there could be outbreaks or incidences of allergens. So 50 years ago, soy protein was not in the big A of USDA or FDA. So, but now it is, because more people consumed that over the years, more allergies were developed. So it might become allergenic in the future, and we do have somebody that is allergic to pea. Rachel, she's been exposed to it in a certain research project, and she became allergic to it. So, but in terms of market trends, so that you know, soy is the giant plant protein in the market. It's been used in many food products. But if you see the percentage of protein products launches, so you have about, in 2012, you have 81% of the protein products are soy-based, whereas pea protein, you only have 7%. But you can see that pea protein growth over the years, going from 7% to 20%, and soy is declining. However, 20% is still low compared to soy. And why is that? Because we have disadvantages yet. So it doesn't have a pDCAASL1. Soy protein has a pDCAASL1. So pea is not a complete protein in terms of essential amino acid and in terms of digestibility compared to soy. Its functionality is not as soluble. Soy protein is not very soluble, but pea protein is worse in terms of solubility. It doesn't gel very well. I'll give you examples on Friday. It just doesn't emulsify as well, so it doesn't function well in different food systems. And we still have flavor issues. So when you incorporate pea protein in a beverage, you can sometimes taste the green flavor, the pea flavor. So I don't know if anybody tasted the Ripple drink, but it doesn't taste good. So it does have some flavor issues. Soy at the beginning started off with a lot of flavor issues, but over years of research, this has been overcome one way or another. Pea has ways to go yet in terms of flavor. Another problem from an industry perspective is, think about pea flour. It only had 20% protein, whereas soy flour had 40 to 50% protein. So there's a lot of other stuff in the pea flour. So you take the yellow pea usually, which is what we produce the pea flour from. It's dried on the land, and you take that yellow dried pea and then you make it into flour, melt it into flour. So only 20% protein. So when you extract that protein to produce a concentrate or an isolate, you end up with byproducts. A lot of starch and lots of fiber. So what do we do with that? It's a waste. So we need to research ways to utilize pea starch or pea fiber in order to make it viable in the industry. So speaking of purification of pea protein ingredients, so like I said, we get the yellow pea. This it's not green. I don't know why I have the green pea here, but usually what's in the industry is based from yellow pea. So you get the dry yellow pea from the land, you mill it into flour, and you get 20% pea protein in that flour. It's not really high protein ingredient, so in order to use it as a protein ingredient, you want to concentrate that protein a little bit. There are different ways of doing that. One common one is air classification. So in air classification, you run it through a type of a mill. And what happens is you separate, this is the starch, and these are the protein components in a flour. So you separate them based on density. Then you get a fraction that is high in protein and a fraction that is high in starch, and low in protein. And the fraction that is high in protein is called pea protein concentrate. And it has about 55 to 65% protein. So it's higher than 20%, but it's still not high or isolate. In order to get an isolate, you want to process it a little bit differently. So air classification is termed dry concentration process, whereas alkaline pH extraction and salt extraction is called wet milling type of production of an isolate. So what you would do is you subject your flour to solubilization at alkaline pH. So the protein solubilizes at alkaline pH, and then you spin it down, and you spin down the starch and fiber, and you have your protein and oligosaccharides and sugar in the supernatant. You take that, and then you precipitate the protein at its isoelectric point. Then you separate it from the sugar, small molecular weight oligosaccharides. Then you end up with a concentrated protein. You neutralize, and then you spray dry, and you get a protein isolate anywhere between 85 to 95% protein. You can do that. This is very feasible in industry. Another way to do it is salt extraction. With salt extraction, you solubilize the protein using low concentration of salt. And then you spin it down, you precipitate the starch and fiber, and you have the solution of the protein in salt. Now, also with that, you have solubles. You have oligosaccharides, some colors, some sugars. You want to separate that from your protein. So you can do it two ways. You can either salt out. You remember that term from fluorinacid? Salt out, that means you add more salt to precipitate the protein and separate from other components. And then you have to wash that salt out. There's a lot of water washes that you would need to do, and that's not feasible for the industry. Water means more money, more energy. So, and then what do you do with all the water waste that you get? So that's why salt extraction is not really used in industry. It's mostly the alkaline extraction. But what you could do with salt extraction, you can solubilize with small concentration of salt, then use membrane filtration to remove everything else other than the protein. Membrane filtration is used in industry, but for whey protein production. But it can be applied for plant protein as well. So if we look at oil seeds, another category of plant-based proteins. So oil seed, like I said, I gave you natural soybean is an oil seed, but there are other oil seeds out there that we produce oil, and we end up with really high protein meals. So canola, for example, is coming up in the market pretty soon. So you will hear about DSM as a big company that's producing now canola protein. They will launch it in 2021. So follow that. Sunflower in Europe, they're working on it quite a bit, also to produce protein ingredient from sunflower. These other crops, camelina and pennycress, are new crops that they're developing here at the University of Minnesota. They're oil seeds, and they could also have environmental benefits, and they're high in oil, high in protein. So basically, to produce oilseed protein ingredient, we want to get the oil out. They're oil seeds, so they expel the oil, and then you end up with what we call a cake. The cake is still high in fat somehow, a little bit, 10 to 15% fat is still there. So what do they do in industry? They use solvent extraction by hexane to remove all of the oil, and you end up with the meal. That meal in oil seeds is mainly protein and fiber. You don't have starch, very small amount of starch would be there. Mostly it's oligosaccharides, small sugars, and fiber. So the protein is really entangled with your cell wall material and all of that fiber. So it's very, very hard to extract. So again, extraction procedure, pH and salt solubilization, but the pH extraction, in order to get those proteins, they're not very soluble at neutral pH, has to be at really high alkaline pH. That gives us really bad protein ingredient, right, Rachel? It smells bad, brown, it's not good. So that's one of the disadvantages really, is how to get the protein out from a complex matrix, and also how do we not get brownie and not get bad flavors. So these are the disadvantages. Protein extraction challenges. Also functionality so far is not great because the extraction of the protein, the methodology to extract the protein is so harsh that it makes the protein not good, does not function very well. Flavor issues, these systems usually are high in polyphenols. They oxidize the protein, they give you that brown color, and they give you this very off-note flavor. Hemp is another source that is becoming, gaining traction and gaining interest. So hemp is a species, it belongs to the cannabis sativa species. However, it's related to marijuana, but it doesn't have high levels of THC. So it has no psychoactive effect. And the hemp is gaining traction not just because of the potential of protein, but the CBD oil that comes from the leaves, mind you, not the seeds. But the seeds have the oil and also is high in, they are high in protein. So we can extract the oil from the seeds, and then we get the meat again and extract the protein. And hemp finally is legal now. That means we can produce hemp on the land and utilize this crop for oil and protein production. So advantages, it's non-GMO as of now. It can be a rotation crop, have environmental benefits, non-allergenic as of yet, and some research has found that it's highly digestible, but it's low in certain essential amino acids such as lysine. Functionality is inferior, but this is based on few studies that are out there. It's not yet studied intensively in terms of best way to extract that protein and utilize it. Single cell proteins. So this is really interesting and gaining a lot of attention as well. Is, for example, utilizing yeast to produce certain types of proteins. So take this example. Have you heard of Perfect Day? Some of you might have heard. So it's a company that produces animal-free milk. Like milk, like the milk you know it, but it's not coming from the cow. It's coming from yeast that has inserted cow DNA. So now the yeast produce casein and whey protein, the same that comes from the cow, and they reformulate the milk in similar proportions that has similar proportions of these proteins in the daily for the cow milk. So you end up with milk that tastes very similar and has similar composition of protein, but it's really coming from yeast. So advantages, we don't need additional land use for production of such type of milk, low impact on the environment. It's daily protein, it's casein and whey, so it has the same texture, same structure, same flavor and color. However, we have disadvantages. We don't know what else is in there. When they take that protein that the yeast produce and they extract it, what else is there that comes with that extract? And also it's genetic engineering. We have consumer acceptability, could be an issue. Macroalgae and microalgae, so also algae can be a source of protein. You can produce high amount of protein per unit area. You can grow algae in an industrial scale and then produce protein flour from the algae. Issues with that, you have digestibility issues with protein, functionality, flavor, color, so still yet to be developed. Mycoproteins, so these are produced from fungus. They're mycoproteins, so they're multi-cell fungus. So they can produce these proteins. They are genetically you can either have the wild strains or genetically modified strains to produce certain types of proteins. And for example, corn is one example of mycoproteins. So it is produced from multicellular, so it's not really called single cell proteins. It's best termed as mycoprotein because it's multiple cell protein. So again, you have fermentation vessels where you feed the fungus with glucose and minerals, and then you harvest the mycoproteins produced. So, good nutritional value, structure that mimics meat, low occurrence of allergenicity, you don't use the land. Disadvantages, bioengineered, it could be. Not all of them are wild type, sometimes you bioengineer them. And then some consumers might not like the concept of consuming fungus, and it's not extensively researched. Insect proteins, it's another one that is gaining traction. You can produce insects with less feed and same amount of protein compared to animal protein. So you limit greenhouse gas production, they can grow on organic waste, and then you can have a conventional production of the protein, and then can be used as direct or indirect consumption. Like you can either consume the insect as is, or you can consume them as ingredients or protein ingredients in food application. Again, extractions are mostly following alkaline extraction. Currently, there are some protein flours from insects in the market, and some products made from those ingredients. So it's high quality protein. And then there are a wide variety of insects that can be edible and can be produced economically. Research is lacking on functionality and extraction procedures and applications, and also there is acceptability issue. Western world versus in Asia, we're still behind in acceptability. And also we have a problem with defect action level. So if you remember from your food analysis, we say 75 insect fragments in 50 grams of flour is acceptable. Above that is not acceptable. So how do we differentiate between defect action level and actually edible insects? So that is something that still need to be dealt with. So for alternative proteins, whether from plant-based or any other sources that are now meat-based, we need to research, and there's a lot to be understood. How can we utilize these proteins in different applications and still maintain nutrition, functionality, as well as flavor? So there is still work that needs to be done in this area. How do we extract them in an effective way and produce a functional protein? What applications can we utilize them in? How can we diversify our crops? So a lot of, for example, pea is bred to increase yield, but there hasn't been much research to breed pea to enhance the nutritional quality of the protein, for example. So this work needs to be done, breed to enhance protein quality. And also secure abundant and sustainable supply. So if we look at new crops like camelina and quinces, so a lot of work needs to be done to secure enough supply on the land so that big industries can have the supply they need that is sustainable for their production. So there's a lot to be researched yet for these alternative proteins. So on Friday, we'll talk more about the structure and utilization of these different ingredients in different applications. All right. Have a good evening.